Hello, let's continue our Sudoku adventure with 8 Maids a Milking by GDC. So we have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We're also going to be drawing paths here. So every maid needs to milk the cow. So we're going to draw a path from each maid to the cow. So like maybe a path like that, a path like that, and a path like that, right? We're just been drawing paths. Paths can go diagonally, but there are some restrictions. They may not branch, so a path can't do this. This would be a branching path. And they may not intersect themselves or each other. So this, what I drew here and then here, is not allowed because they intersect in this cell. Two different paths share this cell. And that excludes the cow, where everything ends at the cow. So these intersect at the cow, but that's fine. That's the destination. And finally, on a path, digits strictly decrease. So whatever digit goes in the maid, say this was 6, we have to decrease 5, 4, 3, 2, 1. In this case, we had, because it was 6 long, we had to go consecutive. But if we kind of beelined for the cow, we could do like 5, 3, 2, 1, right? Or we could do 6, 4, 2, 1, right? As long as we're decreasing, we're fine. So we're not going to repeat, and we're not going to decrease. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Well, there's probably just a lot of path logic to do here. But I want to think about how far away minimally are these maids from the cow, right? This could, like, it would make perfect sense for this maid to just do that. And I think there's no reason it shouldn't. But that's all kind of a uniqueness argument in that it doesn't get in anyone's way if we do that. Whereas if we do something like that, we can potentially get in someone's way, and it's a longer path with more restriction. So I suspect it's like that, but we're not going to draw that until we've proven that's forced. But we know that this can be as low. No maids are 1s, by the way. I think. Yeah. Yeah, decrease from the maid to the cow. So the cow is probably a 1, right? I'm gonna say cow's probably a 1, but this is at least 2, right? No maid can be a 1. So no maid being a 1, that doesn't immediately help. So 2 through 6. I'm not ashamed to do this. This is at least 2 away, even if we go diagonally. Basically, we're as far away as so okay. When we draw a path, the best we can do is get 1 closer in rows and 1 closer in columns. So we just have to look at the longest distance between rows and columns. In this case, the row is the longer distance. And that's how long the path needs to be minimally. So this needs to be at least 3 long. So we can't start with 1 or 2. We got to go 3 through 6, but it can't be a 3 either. This has to be at least 4 long. So we need to be 4, 5, or 6. Right, because we could go 4, 3, 2, 1, but we can't go any lower than that. This is also 4 away, so 4, 5, 6. This is also 4 away, 4, 5, 6. This could be as low as 3. Can it? No, it's 4 away this way. Okay, so it's 4, 5, 6. So this is 1, 2, 3. That's not a 3. So we have a 4, 5, 6 triple in here. Now down here, this is 3 away, so 3, 4, 5, 6. This is also 3 away. Oh, no, it's 4 away this way. 4, 5, 6. Okay, so we have a 1, 2, 3 triple here. All right, so I have my maids penciled. I think I need to think about blockers. Like this, can this really be a 4? Actually, it can be. I'm trying to think about, like, the diagonals really make this harder to think about, but we could beeline straight for the cow and be a 4. If we were 4, this is what we'd have to do, because we're 4 away in both axes. But this here could still be a 3. Oh, sorry. 1, 2, 3, 4. This would also be 4 length, but it can't be. Okay, so this would just be a longer length. That's okay. We can always go longer. Okay, I'm not sure whether that's helpful. What about this one? I mean, I could just do that, or I could do that. this would be 5, but that, I mean, yeah. So I'm just wondering about 4s. I guess we have a 4, 5, 6 in this row. So this is a 1 or 2. Oopsie. This is 1 or 2. So the cow, we never had anything more than 4 away. So the cow is 1, 2, or 3, I guess, because we could go 6, 5, 4, 3. Now, whatever our cow is, let's use gray for our cow, because cows are like black and white. All right, anyway. Whatever our cow is, this gray cell, whatever it is, it's got to go in this box somewhere. And we know it can't ever be on a maid. This gray digit can't be on a maid because it's by definition lower than all the maids. So it can't repeat in the column and it can't go on these 2 maids. So gray is in one of these 2. In this box, I'm not sure. Can't really continue that, can I? It's one of these 3. Okay. Now, any maid value can't be the cow, but that doesn't seem to matter. Now, this being 3 would force all the maids to be from 4, 5, 6. Is that a problem? I don't know if eliminating 3 from here helps too much at the moment anyway. I think I have to start trying to draw paths. I think I need to find a maid that, like maids that interfere with each other in specific ways, but I'm seeing like a lot of flexibility because we can go diagonally. I guess the first question to ask is, can this maid be a 4? In which case it would have to go straight down like this. If it detoured, we'd be... Actually, detouring is also fine. Sorry. I'm used to detouring being a problem because you have to do a C shape, but with diagonals, it doesn't really matter. We could detour quite a bit. It'd still make it to the cow. In 4. I mean, one of these is a 6. Can this be a 6? I mean, I don't see why not. Oops. Whoa. Something along these lines. Got to be 6 long. Yeah, that's 6 long. Okay. So what's our in here? Is it these 1, 2, 3s that are very low? Like, okay, so maybe I should mark which cells can't be on the way to the cow because they're too far away from the cow for their number. Yeah, I think that's a good idea. So, for example, this cell here, I'm going to mark, I'm going to get rid of this gray because I don't think it was helpful. I'm going to mark in gray, a darker gray, cells that cannot be part of any path. Because if they were, even if it picked the biggest digit, it can only reach to here. Right? It can't actually get all the way to the cow. And so that means that this maid must hit this cell. It can't hit another maid because it would cross paths with that maid. And so it must go here. It's the only choice of the 3 cells now. And so now here, this is 3 away from the cow in both directions, but the larger axis is 3 away. So this must be a 3. And now this is still 3 away from the cow, so it is gray because it can't be a 3. This is also gray, and this is also gray because these are 4 away from the cow. All right, this is 4 away from, actually, yeah, all of these are 4 away from the cow, so they cannot be on the, they can't be on the path either. So from this 3, which way can I go? I can't go left. I can't go into any other maid. I can't go into the grays. So I have to go down here. And so this, hold on, is 3 even, sorry, no. There's 2 paths because I can go diagonally here. If I go down here, then this has to be a 2, but it's still 3 away from the cow. So I can't actually do that. So I'm going to go here. It isn't in general not on the path, but it's not on this path. I think with this being a 3, we have to beeline straight to the cow because we're 3 away this way and 3 away this way. So that's probably the easiest thing to say. And that does make the cow a 1. So now we can just mark 1s down here. And this is a 2. That makes this 1 and 2. That makes this a 1. This is 3 and 1, and that's 2. All right. So this is one of our paths. Now this maid has to go here. And then this digit here is not a 1, 2, or 3. So it's 4 or 5, and this can't be 4 anymore. It's 5 or 6. So we can't beeline straight for the cow. Oh, wait, this one looking down places this one. And this can't be a 2 anymore. So it actually doesn't do what I thought. That was a reason. Actually, no, it can do what I thought, because it just has to be bigger than 1. We don't have to go consecutive all the time. Never mind on that. So we're at least 5 away. So we have to like kind of take a circuitous route here. These are 4, 5, 6. Big digits close to the cow are fine. It's small digits far from the cow that are not fine. So like 1s are never on our path. So this is either going to go diagonally or left. Do I care? Not at the moment. Oh, we can place the 1 in this column. So that's not on the cow. And so now we actually do have to go left, and then we have to avoid this maid. So we go here. So this is going to be 3, 4, 5, but it's not a 3, which means that's not a 4. That places this as a 4. That makes sense, by the way, but it doesn't have to be. And so now this is 3 or 4. So we can't go straight to the cow. We have to be at least 3 cells away from the cow. That's interesting. And this is not less than this. So we can't go up. We can't go down. We can't go straight to the cow because we're not 3 away. Oh, no, sorry. We can go 3, 1. Never mind. Oh, but this needs to have a length of 5, right? Wait, no. I've been thinking about this a little bit wrong. You can think about it from minimums, but not maximums, right? If this is a 5, that doesn't mean we have to be 5 length. It just means we can be 5 length. But we could go straight to this cow and be fine, right? This isn't the length of the line. Nothing in the rule says that. It's just the minimum length of the line. Sorry, it's the maximum length of the line. Not the minimum. It's the maximum length of the line is what's in the maid. Gotcha. Okay. Sorry about that. I wasn't thinking about that quite right. So, okay, if I were to go down here, and if I were to go down, I only have one direction to go from there, which is left. And now there's nowhere to put 6 in this box. So I have to go here instead. And then this is where 6 goes. And then this has to decrease. And this is minimum 4. So we're going 4, 5, 6 here. Now, I think once we're next to the cow, there's no reason to do anything but go to the cow. So I'm just going to do that. 3, 4, and 5 here. That's our 6. That's 5 and 6. This is not a 3. This is 4, 5. And this is 2, 3. Okay. I got to get these 2 maids to the cow. Doesn't seem hard. So again, I think there's no reason to do anything but just have this maid go to the cow. Okay, down here we need the 2 and the 5. And up here we need 3, 4, 6. That's not 6, that's not 3. And here we need 2, 4, 5. All right, we're penciled. So, I mean, it feels like we just do this, but I don't know if that's forced. I don't need all these grays anymore here. I might want to try to gray some cells. Do we have small digits here? This 2, 3 can't be on the path. Actually, 3 would... Yeah, we're 3 away, so 3 would work, but not 2. Darn it, we're 3 away. I don't think there's anything I can gray out by the digits. Okay, so if we went here, 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 this still doesn't even restrict this from being 2 or 5, as long as this can be a 6. Maybe there's some Sudoku I haven't noticed. Let me just make sure this is good. 5, 4, 3, 1, 6, 5, 4, 1, 4, 3, 2, 1. Oh, these 2 have to get to the cow as well. Okay, so actually, we should keep this grayed. So from this, it's clear that this maid has to go here. It's the only way, the only place it can go. And now this maid has to go here. So this is less than 5. This is less than 6. Now from here, it would make sense to beeline for the cow, but we don't necessarily have to. I think a 2 doesn't work here because it's 3 away from the cow. So this has to be a 4. That makes that 3 and 5 and 2 and 3. That makes these not 5s. That's not a 3. These aren't a 4. Okay. 2 doesn't work here either. It's 3 away from the cow. So that's our 5 and that's our 2. 2 and 5. Okay. Now we have this kind of 4-6 deadly pattern that we're going to have to resolve with a line. So we can just go 4-3-1. I don't think there's any reason to do elsewise. How about this maid? This maid can just go 2-1, so it's fine with being 4 or 6. I'm wondering if is there other two solutions to this? Let me think about this. So one option is just beeline straight down here, and then this can just do this, and then we end up resolving the 4-6 that way. I'm wondering what's the problem though of doing this? Oh, sorry, we can't go here because 4 and 6 is not smaller than us. So actually, no, sorry. At least the one definite logical step we can make here is going from the 4 to the 3, because we can't go to the 4-6 here. It's too big. Now from the 3, I think we could technically go to the 2 and then the 1. I don't know why we would, but we need to prove that that's not going to work. This path, even if it goes to the 5 first, then the 2, it's always taking the 2, right? There's no way to avoid that because this 4-6, we could technically go up to the 5, to the 4-6, then the 1, but now there's no way for this top maid to make it to the cow. We've blocked this maid up here. I know there's a way I can just draw this and be done, but I want to prove it's the only way to do it. So this always takes the 2, because if we try to avoid taking the 2, we end up blocking that top maid. So I don't know if it goes straight to the 2, but it definitely always takes the 2. So the 2 is not allowed to be taken by this guy, so it has to go straight to the cow. And now here, we're going to have this maid go through here. This is a line for sure, and this is a line. That's what I should have drawn. So this maid has to go to here, but if we took a detour to the 2, that would be bad. If we took a detour to the 4-6, now one of these has to be 6, and that's bad. And I can't go down to this 5 because it's too big. We already have a 5 on our line. So we're going straight down to here, and that makes this 4-6, 4-6. And now that this is a 4, it can't go to the 5, it has to go to the 2. So yeah, I think that is the unique solution there. Cool. Very nice puzzle, GDC. It's kind of drawn the way you'd expect it, but I mean, I think that's kind of forced. But it's nice that there was a logical path to prove that. I think there's two very different kind of solvers. There's the solver that's like, I'm just gonna draw what makes sense and see if that's a solution. But then there's the solver that's like, I'm only gonna make moves that are logically proven as the only option. And so I like the latter. I find that more fun, but it's definitely not as fast. Cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.